This lesson is on simplifying rational expressions. I'm going to start with a definition. So, rational expression is an algebraic fraction whose numerator and denominator are polynomials. So, an example of this could be 6x over x, or 5m plus 3 over m plus 6. Alright? And if we think back to fractions, that's essentially just taking whatever is on top and dividing it by what is on the bottom. And the one number that we can never divide by is 0. So that means if we have a variable on the bottom, we are going to have some restrictions. We can never divide by 0, which means on this first problem here, our bottom number, x, can never equal 0. Because if it did, then we would be trying to divide by 0, which is illegal. Right? So then if we look at our second one, we set our bottom part, m plus 6, equal to 0. We solve for m, get negative 6. Negative 6 would make the bottom 0, which means we never want it to equal negative 6. So once again, that'd be illegal. And, the math cops could be coming for you, right? So the most important part of rational expressions is to remember the bottom can never equal 0. Alright, so we're going to do some examples. So here's one. The directions are to simplify and state the excluded values. And again, the excluded values are the values which makes this bottom part here equal to 0. We're going to start with 9x squared y times z all over 24xyz squared. So the first part we're always going to do is we're always going to state our excluded values. Always do that first. So we set our 24xyz squared equal to 0. And notice we have 4 different things multiplied together to equal 0. So we can use our zero product property and say that one of them has to equal 0. Well, let's look at the first part. It's 24. We know that 24 can never equal 0. So we just kind of ignore that part. X, though, can equal 0. Alright, so that would be an excluded value. Notice how we have a slash through the equal sign? That means x cannot equal 0. Because if x equaled 0, then our polynomial on the bottom here would equal 0, and again, that would be illegal. Next, we look at the next part, and we set y equal to 0, and we do not want that to happen, so we put our slash through our equal sign. And the last part is z squared, set equal to 0. Now, if you remember, z is equal to z times z, and again, we can use our zero product property because we have 2 things multiplied together to equal 0. And here we would just say z cannot equal 0. And you don't have to write both of the z's because z can only be one number in our equation. So we couldn't have one z equaling 1 and the other equaling 2. So both z's are going to have to equal the same thing. Alright, so our excluded values would be x cannot equal 0, y cannot equal 0, and z cannot equal 0. The second part is to simplify. So we're going to look back at the whole part. We're going to simplify that. So if you think back to fractions, if you had like 3 over 6, we could pull 3 out of both of them. Okay, so 3 would be our greatest common factor. Since we're multiplying 3 times something, our parentheses here, then we can cancel them out. And we are left with 1 over 2. So we're going to do that same thing with our polynomial. So we're going to find our greatest common factor between the top and the bottom. Alright, so if we find our prime factorization of 9x squared yz, that might help us find our greatest common factor. So 9 equals 3 times 3. Then we have our x times x and our y times z. And then we have 24x y z squared. And that equals 2 times 2 times 2 times 3 times x, y, and then 2 z's. Right, so now we want to look for the things that they have in common. So they have 1, 3, and they have an x, a y, and a z. So 3x, y, z would be our greatest common factor. So we pull that up front, 3x, y, z. And that's going to go on the top and the bottom because we can pull it out of both of them. That's why it's called the greatest common factor. And then we need to see what's left on the top. We see that there's a 3 and an x. So we're going to put 3x in our parentheses. And if we look to see what's left on the bottom, we have a 2, 2, another 2, and a z. That's going to be 8z. And then, since we're multiplying with our 3xyz times something here on both of the top and the bottom, we can cancel them out. Our answer would equal 3x over 8z. Now, a common misconception would be if we have x squared plus 2x minus 5 over x squared minus 5x plus 2. Let's say this is our example. A lot of people will try and cancel out our x squares here. They see an x, so we'll try and cancel those out. That is actually also illegal. So we can only cancel out if we have a greatest common factor pulled out and then it's multiplied by something else. So like 3x times 2x minus 1, and if we had a 3x on the bottom multiplied by, let's say, 2x squared plus 5. Since this 3x is being multiplied by the rest of the stuff that's on the top, and this 3x is multiplied by the rest of what's on the bottom, then we can cancel out. Right? So we cannot cancel these x squareds out in the top because we are adding and subtracting. So you can only do it if you're multiplying by what is left in your polynomial. Alright, let's do another example. So the directions again are to simplify and state the excluded values. We always state the excluded values first, which means we set the bottom equal to 0. So a squared plus 4a plus 3 equal to 0. And this is just solving polynomials. So if you are having difficulty solving polynomials, then you can check back to the 10.6 video on solving polynomials, and that will give you more examples on how to do this. Alright, so to solve this, we need to factor. So we're going to make our little chart. We have an A and an A, 3 and a 1. So in our parentheses are A plus 3 and A plus 1. And that still equals 0. Now we have two things multiplied together to equal 0, so that means we can use our zero product property. Say that A plus 3 equals 0 and A plus 1 equals 0. Solve for A in both of them. And since we do not want these to equal 0, we say A cannot equal -3 and A cannot equal -1. Now we look at the first part, which is simplify. So let's look at the top here. A plus 3. We cannot simplify that anymore. So sometimes on the top you will look for a greatest common factor, or you may have to factor. it, but a plus 3 cannot be factored, so we just leave it at a plus 3. On the bottom, though, notice how we factored here when we were stating our excluded values. We are going to use that factored form. So we have a plus 3 and a plus 1. And that's the benefit of doing the excluded values first, is because usually you already have it factored, so it's just that much easier to simplify. Now if we notice, we have a x plus 3 up here and an x plus 3 down here. And we can in fact cancel these out, because our x plus 3, we can multiply that by 1, right? And we can cancel those out. So what's left on the top is going to be a 1. So it is not 0, right? So essentially if we think back and we look at 3 over 3, since we cancel out the 3's, that does not mean we have 0 left. And in fact, we would have 1. So that's why we have a 1 left on the top. And we have our a plus 1 left on the bottom. And there is your simplified form. Alright, so let's look back at our steps. So, step 1 would be to find our excluded values. So to do this, we usually need to factor the bottom, factor, and set equal to 0, and then solve for the variable. Okay, and then step 2 would be to simplify. To do that, we find our greatest common factor, or we have to factor either the numerator, the denominator, or both, right? And then we cancel out our similar